Professor Zawolo, and today we're going to be going over yet another section of the West African Examination Council WAEC Senior Secondary School Certificate Mathematics Examination for Liberian schools. Today we're going to be going over a section on plane geometry. In this section we're going to be talking about different kinds of angles and intercepts. Let's see how we're going to be going over here quickly. So we're going to be learning about the measure of angles formed by parallel lines that have been cut by a transversal, and we're going to find the measure of angles and segments using proportional relationships, setting up proportions that we can use to find the measure of segments. So first of all, let's talk about what is a transversal. Okay, so let's go quickly. A transversal basically is a line that intersects two different lines in a plane. So for example, we have a line M, we have another line here, the green and the purple line. The white line here is a transversal intersecting the green line, line M, and the other line N. Alright? When this happens, 8 different angles are formed. Those 8 angles form some special pairs of relationship. We have corresponding angles, we have alternate angles, we have consecutive angles, we have some vertical angles. So let's look here for example. We can see clearly that angle 1 and angle 4 are vertical angles, 2 and 3 are vertical angles, 5 and 8 are vertical angles, and 6 and 7 are vertical angles. We can also see what we call corresponding angles. Corresponding angles are angles that are in the relatively same position with respect to the line that is cut by a transverse, to the lines that are cut by the transverse. For example, angle 1 is on top of this line and on the left of the transversal, as angle 5 is on above and on the left of this line. So angle 1 and 5 are corresponding angles. 3 and 7 will be corresponding angles, 4 and 8, and then 2 and 6. Then we have some angles we call interior angles. The interior angles will be 3, 4, 5, and 6. Those are all interior angles. Now, angle 3 and 6, we call them alternate interior angles, and angle 4 and 5, we call them alternate interior angles. Angles that are outside of these two lines, we call them exterior angles. So the exterior angles here will be 1, 2, 7, and 8. And one exterior angle, say to the left on top of that line, and the other one at the bottom will form an alternate exterior angle pair. And so angle 1 and 8 is an alternate exterior angle pair, and angle 2 and 7 will also be. Okay, so we see here we have several kinds of angles. We see that if these two lines, so we see that angle 1 and angle 4 will be equal because they are vertical angles. Angle 2 and 3 will be equal because they are vertical angles. Angle 1 and 2 will be supplementary because they form a linear pair. 3 and 4, all this listing of supplementary angles and vertical angles you can see. Now, let's talk about the relationship between those special pairs of angles when the lines that are cut by the transversal are parallel. So, basically, when those lines that are cut by the transversal are parallel, then the corresponding angles will be congruent, alternate interior angles will be congruent, alternate exterior angles will be congruent, and consecutive interior angles and consecutive exterior angles would be supplementary. Remember, corresponding angles, alternate interior, alternate exterior, they are going to be congruent, and these will be supplementary, meaning they add up to 180 degrees. So as we can see here, we can identify several corresponding angles here. We see the corresponding angles. We see the two angles that occupy corresponding position, like 1 and 5, 2 and 6. So you see them. This is a listing of corresponding angles. Let's move to alternating angles. So it's a good thing to watch this and go through this. So the alternate interior angles here will be 3 and 6, 4 and 5. The alternate exterior angle will be 1 and 8, and 2 and 7. And we know those angles pairs will be congruent. Now let's go to consecutive angles. Angle 4 and 6 will be consecutive interior angles. 3 and 5 will be consecutive interior angles, and they are supplementary. And then angle 1 and 7 and angle 2 and 8 will be consecutive exterior angles, and they too are supplementary, as you can see. So now let's see how we can use those rules to apply to find a measure of the angle. So basically, we have to find a value of x in the diagram. Basically, what we're going to show you here is this line and that line are parallel. So we said that if two lines are parallel and are cut by a transversal, then the corresponding angles will be equal. So if this angle is 80 and this line is parallel to this line, so the angle right up here will be 80 degrees. So then right here I have a linear pair. So if this is 80, 80 plus the angle over here must be supplementary. So 80 plus what will give you 180? 80 plus 100. So the angle over there is going to be 100. Now we have a triangle over here. So since we have a triangle over here, we know that the sum of the interior angles of a triangle is going to be 180 degrees. So we're going to do x plus 50 plus 100 equals 180. We have x, 50 plus 100 is 150 equals 180. We subtract 150 from each side. We'll have the x to be equal to what? 30 degrees. Some of these things you didn't really have to lay out, but that's how we're going to find the measure of angle x. Remember, we used the fact that parallel lines are cut by a transversal. The corresponding angles are congruent. So if this angle is 80, this is 80. We have a linear pair over here, so they are supplementary. 80 plus 100 will give you that. There's another thing we're going to learn later on about the sum of the remote interior angle is equal to the exterior angle away from it. So that is 50 plus x must be equal to 80. So how we use that approach? By saying x plus 50 must be equal to 180 equals to 80. Subtract 50 from both sides. We're going to take out the same answer, which is 30. Okay, let's try a second example. Okay, so to do this problem here, we have to find the value of x in this problem. Now, this angle over here and that angle over here, they form a linear pair. But we cannot, even though they are supplementary, but if we were to write 5x plus 35 plus y equals to 180, we'll not be able to do much because we have two variables and we have one equation. So that's going to be difficult for us to do anything. So that is not going to carry it for us. Now understand, before I go further, let me indicate here that these two lines are parallel. So then I can see that angle y and this angle down here are corresponding angles, and corresponding angles would be congruent. So quickly I find that y will be equal to what? 45 degrees. That is using the corresponding angles theorem or postulate. Now that I know what y is, let me redraw this so that you see what I'm going to do next. So I'm going to put y is 45, so I'm going to put 45 over here. Then I put 5x plus 35. I can put that 45 over here. Now, clearly I know that this angle and that angle are supplementary, so I can proceed to solve this by writing 45 plus 5x plus 35 equals 180. And I can add like times 45 plus 35, that's going to give me 90, right? And so I have this 80, right? Yes, 80. So I have 5x plus 80 equals 180. Subtract 80 from both sides. I have 5x equals 200 divided by 5 divided by 5. X will be equal to what? 20. So x will be equal to 20. And we can double check and see. 5 times 20 is 100. 100 plus 35 is 135. 135 plus 45 will give us 180. So again, here we're supposed to find y, but we're supposed to find x. But we had to go around this by first finding y and then using y to find x. That is something that we want you to become very comfortable with in mathematics. It's a very common problem. But the problem is that most people think that no, it cannot be this way. Okay, let's go to number 3. So yeah, okay, here's a problem where we have to set up proportions. So we see that this line over here is parallel to this line. So, and they form two similar triangles. So we can use the concept of the similar triangle they have formed to be able to set a proportion. Now, we have been told that AB is 4 meters. We've been told that CD is 15 meters. What other information we've been given? We've been given that BC is what? 5 meters. And they want us to find the length of what? DE. Now, I forgot to put an E over here. This is DE. We don't know what DE is. So DE is equal to X. So let's set up a proportion. I'm going to say, let's call this the leg over here. This one. 4M. 4. No, let me set up a proportional statement first. I'm going to say AB is proportional to BC as what? DE is proportional to CD. And I could do it up all the way around, like BC to AB and the rest of it. Now, what's the measure of AB? AB is 4. What's the measure of BC? BC is 5. What's the measure of DE? X, that's what we don't know. What's the measure of CD? 15. We can cross multiply by multiplying this by this. We get 60. Multiply. We get 5x. We divide by 5. Divide by 5. And we have x equals to what? 12. So here we use proportional relationship to be able to solve involving similar triangles. So number 4 is a fairly easy problem. What we're going to do is to find the measure of almost every angle in here. So basically, we see that over here we have a linear pair. Linear pairs are supplementary. So I don't know, I can call this y. I can say that 42 plus y equals 180. Subtract 42 from both sides. I see that y is equal to 138. So y is equal to 138. So I see that this angle and this angle must be, these two angles over here must be supplementary. Besides, I think one of the things we want to show here is these two lines are parallel. These are parallel. So also we can say that if this is 42, this corresponds to that. That's going to be 42. All right, and these two angles here they are consecutive interior angles, so they must be supplementary. So I could say here that x plus 42 must be equal to 180 minus 42 minus 42. X should be equal to 138. Now, there are many other ways you go about this, because, again, many other ways. So we'll just focus now for this to see how we can get this, but I could use the factor between this and this. And to get that, there's so many things I could possibly do here to get that, correct? So x here will be equal to 138. So again, this is basically what we have on this section. We're going to come with subsequent videos focusing on even more challenging problems. But our own research of the WAEC tests that have been released in the last few years has shown that the problems on this section are not in a much harder than these. So we gave you the basis, we gave you the information. What you need to do now is to go and visit our website and do more practice on these kind of problems. And we think you should be able to do well. Again, thank you. This has been a production of the Foundation for Equity and Excellence in Education in Liberia, a foundation dedicated to providing high-quality content instruction for Liberian children. We are on the web at www.feedliberia.org. You can visit us on YouTube. You can subscribe to us on YouTube. You can follow us on Twitter, and also like us on Facebook. Thank you.